let's see how we'll do about the next equation of motion. So, but before then, let's list out the equation of motion that we've derived so far. The first one, V equals to U plus AT. That was the first one. The second one was average velocity equals to final plus initial over 2, which is still the same thing as displacement over time. So that was the second one. The third one we derived was displacement S equals to initial velocity times time plus a half of what? Acceleration times time squared. So the fourth one is what we are trying to get now. So now the fourth one, what you will notice in this that will prompt us to get the fourth one is this. If you look at the first equation here, it has final velocity, initial acceleration, and time. So those are the parameters you can get from it. But what about displacement? What about height? What about distance? You can't get displacement or distance or height from this first equation. Then you look at the second one. The only thing you can extract here is final velocity and initial velocity, displacement, and time. There's no acceleration here. You can't extract acceleration from it. So you look at the next one, third one. The third one now has displacement, or you say height or distance. It has initial velocity, time, and acceleration, but it doesn't have final velocity. So the next equation that we're going to derive is the one that has what? It has both initial velocity, final velocity, acceleration, and what? Displacement. So how are we going to get that one? We are going to get that one leveraging from the first equation here. So from the first equation that you have V equals to U plus AT. So having reached it, we say square both sides. Square both sides of the equation. So when you say square both sides, you take square of both sides. That will be V raised to power 2. That's V squared equals to U plus AT. You square it. Remember, you are not squaring individual terms. When they say, the concept of equation, for equation to be balanced, whatever you do to the left-hand side, you also do it to the right-hand side in exact measure. So when you say square both sides, that means all the terms here, you combine it as one squared. But however, it's only one term that is here, V, so we square. Then you also do the same thing on the right-hand side. However, there are how many terms on the right-hand side? 1, 2. So you bracket it as one entity and square it. So that will keep the equation balanced. Okay. So we now have that V squared equals to this. What this square means is U plus AT times another what? U plus what? U plus AT. So V squared equals to, we now expand this bracket. So how do we do this expansion? You say this first U times, that's the first U in this bracket times the first U in the second bracket, that will be U squared. Now this same U will now multiply with the second term in the next bracket, that will be plus what? UAT. How to do this kind of multiplication is that each term in the first bracket will multiply with all the terms in the second bracket. So for this U here, it has multiplied with the first term here, which is U, and give us U squared. Multiply with the second, give us UAT. So now move to the second term in the first bracket. So this will be TAT times the first term in this bracket times U. That will give us plus another UAT. And then this same AT will multiply with AT here. That's the second term in the second bracket. That will be plus what? A squared T squared. Haven't done that. So we simplify further. V squared equals to, we have U squared here. You see we have UAT, they're in two, so they are like terms. UAT plus UAT, they are like terms, so you can add them. So when you add them, that will be 2 UAT plus A squared T squared. So we proceed. So the next step is this. You are going to look for a way to factor out 2. Well, I'll say 2A from the on the right hand side from the second and third term. We're going to look for a way to factor out 2A. However, we can factor out A. But how about 2? How can we factor out 2? Because there is no 2 in the third term here. So let's see what to do about that. U squared plus, I can write 2A over 2A, watch carefully, times 2UAT plus A squared T squared. Now what I've done, I've not changed anything in this equation, because 2A here divided by 2A here will give us what? 1. And 1 will multiply to open this bracket, which will return us to what we initially had here. So we proceed. V squared equals to U squared plus. However, we are going to send in the 2A on the bottom, that's the denominator 2A, into the bracket. So left with 2A outside here, into 2UAT divided by 2A plus A squared T squared divided by 2A. The goal of what we're trying to do is that we are trying to form the third equation that we got here. We're trying to represent it here. So that we now have V squared equals to U squared plus 2A into, from here you can see that 2 will cancel 2, A will cancel A. What will be left is what? UT plus, from here you see this A will cancel one of the A's here. You know here there are A times A, that's 2 A's. A times A, so this A will cancel one of those A. So you are now left with 1 over 2 of what? AT squared. 1 over 2 AT squared. So we proceed. Now you look at this expression in this bracket. What does it look like? Because you recall that our displacement, our third equation of motion that we developed, our displacement equals to what? UT plus a half what? AT squared. So if you substitute that here, you now have that V squared equals to U squared plus 2AS. So this is the fourth or the last equation of uniform motion or rectilinear motion that we develop. So you see that this one has final velocity, initial velocity, acceleration, and displacement, or you say distance or height. However, it doesn't have time. So that means most time for you to answer some questions in WAEC, JAMB, and the rest, you will need to apply maybe two of the two of the equations, sometimes the three, sometimes only one, depending on the questions. That's why I'll advise you follow us on our WhatsApp channel and group so that we make WAEC and JAMB questions with respect to this kind of topics. Bring question banks on it so you attempt and get yourself conversant with it. So, and see how to combine each of the equations to get what you want. So now, to round up everything, let's list out the equations that we've looked so far or we've derived so far. The first one is v equals to u plus at. Now the second one is average velocity equals to final plus initial over 2, which is the same thing as what? Displacement over time. And then the next one we developed was displacement will be given as what? U times t plus a half at squared. And then the last one we developed was what? V squared equals to u squared plus 2as. So, and then that's the fourth one. However, the most important equation among these four is number 1, number 3, and number 4. This number 1, 3, and 4 could answer any question under uniform motion that has to do with acceleration, time, displacement. That's for O-level exam. That's JAMB WAEC physics. So these three, the first, the third, and the fourth, are the most important ones. So on the description below, you follow it to join our group where we solve questions on this topic, on these various topics. We solve a lot of questions on it so that you see how to apply the formulas. All right.